In this video, we are going to be continuing with the West African Senior School Certificate Exam, Chemistry Paper 2, starting from question number 30. But before we continue, I want to thank those of you who have taken your time to subscribe to my channel. And for those of you who haven't subscribed to this channel, please like this video, share to other learners, and most importantly, take some time and subscribe to the channel so that other subsequent papers that we are going to be solving, they'll be coming directly to you. And before we conclude, any student who is facing difficulty in solving some particular questions, please, we are here to assist you succeed in your exam. Channel the questions to us and they will be of assistance to you. Let's get started. Question number 30. What is the oxidation number of boron in Na2B4O7? Oxidation number of boron in Na2B4O7. By now, you should be versed with the rules for calculating oxidation number of atoms in a compound. Rules for calculation of oxidation number. For question number 30, Na2B4O7. You know that the rule says that sodium has an oxidation number of +1. Oxygen has an oxidation number of -2. We don't know for boron. So +1 times 2 of the sodium, because there are 2 atoms of sodium. Then there are 4 atoms of boron. So since we don't know the one of boron, it is 4 times B, which is boron. Oxygen is a -2. It is -2 times 7 atoms of oxygen, who have a -14. And the rule says the sum total of all the oxidation number of a neutral compound is equals to 0. And that is why it is equals to 0. So now it is 2 plus 4b minus 14. And you will realize that 2 minus 4b, that will be minus 12. So it will be 4b minus 12 equals to 0. Making b the subject, we are dividing +12 by 4. And b will be +3. Now, b, which is boron, is equals to, has an oxidation number of +3. We go now to our oxidation, to our answer column. +3 is, the answer for +3 is C. C is the right answer for +3. Now we go to question number 31. Which of the following species undergoes oxidation during the electrolysis of dilute sulfuric acid? Remember, fellow learners, that when a substance is dilute, it means it has water in it. So we are not only going to look for sulfuric acid, water is also one of the components. So now let's see how we can look for the electrolysis of dilute sulfuric acid. And from there, we will know which one is undergoing oxidation and which one is undergoing reduction. Now, for the electrolysis of dilute sulfuric acid, because it has water involved in it, when sulfuric acid ionizes in water, it's going to have hydrogen ion and the sulfate ion. Now, when water ionizes too, it's going to have hydrogen ion and the OH ion. Now, these two, the thing is, they are going to be, there are 2 electrodes. The cathode, which is the negative electrode, and the anode, which is the positive electrode. Which of them is going to be deposited at the anode and the cathode? If you look at the electrochemical series, the ions right down, the anions and the cations that are right down at the electrochemical series are the one to be deposited. For instance, the cation, we have only hydrogen ion there. So hydrogen ion is the one to be deposited at the cathode. Now for the anions. The anions, there are two anions there, the sulfate ion and the OH ion. Now, if you look at the electrochemical series, you will find that the OH ion is the one right down below at the electrochemical series. So it is the one that is going to be deposited at the anode. So we now say it is deposited at the anode. Now these are the only two ions that are involved, at the anode and at the cathode. At the anode, there is going to be oxidation because the OH ion is going to be oxidized. How is it going to be oxidized? The electrons that it has gained is going to lose those electrons, resulting in what? In water and the oxygen that's being released. That is the equation there. Then at the cathode, it's going to undergo reduction. How is it going to undergo reduction? The hydrogen ion, the electron that it has lost, there's going to be gain of electron this time around. There's going to be gain of electron this time around, and it will now result but in hydrogen ion that is released at the cathode. So now our answer is oxidation is going to be taking place at the anode. Oxidation at the anode. And let's go to our answer column. Which of the following ions species undergoes oxidation? The one that is going to undergo oxidation at the anode is the OH ion. That is the OH ion, B. The OH ion is going to be undergoing oxidation at the anode. Undergo oxidation at the anode. Now we go to question number 32. Question number 32 has to do with some organic compounds. Now, C3H4 belongs to the same homologous series. It belongs to the same homologous series as C5H6, C5H8, C5H10, C5H12. Now, what you need to do in this type of question is the organic component or the organic the molecular formula that has been given to you. What you need to do is you need to write the structure there, write the structure, and to determine which of the homologous series this one belongs. So now, if I should write this structure here, is not an if I should write this structure here, the structure of C3H4, this is how the structure is going to look like. This is how the structure is going to look like. This is how the structure is going to look like. This structure shows that is C3, 1, 2, 3, and 4 hydrogens, 1, 2, 3, 4. It shows that it is a cyclopropene. It is a cyclo. It is not propane, but it is propene because of the dysfunctional group there, the double bond. So the cyclopropene, it is cyclopropene. But now, for the homologous series for this is an alkene. Homologous series for cycloalkanes, because there is cycloalkane and there's also cycloalkane. For homologous series for cycloalkanes, this is the formula CnH2 minus 2. Now, because since it is 3 here, 1, 2, 3. This is 1, 2, 3. There are 3 carbon there. So it will say C3. Then how many hydrogen will be there? It will be 2 times 3 is 6. 2 times 3 is 6. 6 minus 2 is 4. This is what we have got here. Now, for the compound that we are saying, the compound, this one is going to belong to what? It is Cn H2n minus 2. So for this, the question is, this one is going to belong to which of the four? C3 belongs to the same homologous series as what? We have 5 carbon. If we take the 5 carbon here, and we substitute here. Okay, C5, H2, then it's 2 times 5 is 10. 10 minus 2 is 8. So it is C5H8. It's going to belong to the homologous series as C5H8, and which is B. So our answer for this, for 32, is B. (32) is B. Now we go to question number 33. Alkanes can be prepared by A. Heating the sodium salt of arcanoic acid with soda lime. Okay, preparation of alkanes. Preparation of alkanes, as I said, let me go to you. Alkanes are prepared. This is another way you can prepare alkanes for 33. Alkanes you can prepare, that is soda lime, sodium, this sodium, arcanoid with the soda lime will have an alkane. So now, that is because a molecule of what 1 mole of carbon dioxide will be released. In that case, we are saying here that alkanes can be prepared by heating sodium salt of an arcanoic acid with soda lime. Sodium salt of arcanoic acid with soda lime. So our answer for question number 33 is A. 33 is A. Now, because we said heating this one with soda lime will remove a molecule of water. But there is another method you can use in the production of alkane. You can use the same plus sodium hydroxide or calcium hydroxide will have this plus sodium carbonate. I use sodium ethanoate plus this plus calcium oxide. It gave us methane and sodium carbonate. So that is another method you can do. But we were dealing with the first method using soda lime. Okay, question number 34. Question number 34 takes us to empirical formula. Empirical formula. In calculating empirical formula, in calculating empirical formula of a compound, now the empirical formula of a compound is C5H7N. C5H7N. If its relative molecular mass is 162. If its relative molecular mass is 162, what is its molecular formula? Now, to calculate the empirical formula for this is a compound that has been given, the compound has been given, and the molecular mass has been given. We are now told to what is its molecular formula. Only the empirical formula has been given, and the molecular mass. What can we do to have the molecular formula of this compound? We have been given by the molecular mass. So the method to do this, let me show you precisely. Now we have C5H7N to the power n equals to 162. Then CCN. Now this is C5H7N. We are putting an n here because we don't know the number of atoms of each of the elements that are going to be added up to give us this molecular mass. Now, so if we sum up all these and multiply by the relative atomic masses, we are definitely going to have this molar mass. So now, let's put n there. So see, there are 5 atoms of carbon. So now, the 5 atoms of carbon, carbon has a relative atomic mass of 12. So 12 times 5, we have 60N. Hydrogen has only 1. 1 times 7, we have 7N. Nitrogen has 14. 14 has 14, and there's only 1 atom of nitrogen. So 14 times N will have 14N. The we sum of all the N's will be equals to 162. The total will be 81N equals to 162, making N the subject we will have N equals to 2. And if we now substitute N in our equation here, let's say N is equals to 2. Therefore, it will be, there are 5 carbon atoms times 2, we have 10. Now there are 7 hydrogen atoms times 2, we have 14. Now we have nitrogen atom, which is 1 times 2, we have 2. Therefore, the molecular formula that we are looking for will be C10, H14, and N2. And if we go to our, if we go now to our answer column, we will see that the answer for this equation will be 34. The answer for this will be C10H14 N2. Our answer for 34 will be C. Our answer for 34 will be C10H14 N2, which will be C. Let's proceed to question number 35. At question number 35, it reads, which of the following compounds react readily with sodium to liberate hydrogen? Which of them will react readily with sodium to liberate hydrogen? Okay, that's good. What we need to see here is that alcohols or alkanols, when they react with sodium, to form what we call the salt of the alkanols. So in that case, for example, sodium alkoxide. So now, when the alkanol reacts, or when the alcohol reacts with sodium, is going to form what we call sodium alkoxide. It's going to form what we call sodium alkoxide. And when it forms sodium alkoxide, there is a gas that is being released, and that gas is hydrogen. So now 35, let's say 35 here. 35 here, we have 35. I say alcohol or alkanols, when they react with sodium, when they react to sodium, they form what we call a salt, or what we call sodium alkoxide, and a hydrogen gas. So look at this. This is propan-2-ol. This is propan-2-ol. Propan-2-ol reacting with sodium. There is what we call sodium proposite. Sodium proposite. It's proposite because we have 1, 2. It is not ethosite. It is proposite because it is from propanol. From propanol. Sodium proposite. If it was 2 carbon, we would have said sodium ethosite. But since it is from 3 carbon propanol, we are saying it is sodium proposite. Then plus a hydrogen gas that is being released. Let's go now to our answer column and see if we can find an organic compound, which is that one. And the organic compound that can react with this one here was C. Question 35, we have a C as our answer. Thank you. Question number 36. 36, what is the IUPAC name of the compound below? That is, they are saying that what is the International Union for Physical and Applied Chemistry name of the compound below? That is IUPAC. Now, if you look at this name, we have this, the functional group here. The functional group here is an alkyne. It's an alkyne functional group. But from the alkyne functional group, we have 1, 2, 3, 4. They are altogether 4 carbons. They are altogether 4 carbons. And the side chain there, the alkyl group there is a methyl group. Now, let's rewrite this and follow the IUPAC system of nomenclature in writing this. This is the compound 36. This is the compound, and how do we do this? We can, okay, this is the compound. We want to, in this compound, this is how we do it. First of all, we have to name it. We have to identify the functional group. The functional group here is an alkyne, that is a triple bond. It's an alkyne, that is the functional group. And we will have to start naming, but from where the functional group is. We cannot name here. We cannot use where the branching is. We cannot use where the branching is because the rule says enumbering the parent chain. This is the longest chain is the parent chain. Enumbering the parent chain, double and triple bonds have priority over alkyl groups and halogen substituent group. So we cannot say because the branching start here, this is the shortest branching. We want to start but from here and say this is the first carbon, this is the second carbon, and this is the third carbon, and this is the fourth carbon. No. But because double and triple bonds are given the priority, we have to start but from here. And this is the functional group. For that purpose, we have to, this is the first carbon, this is the first carbon, this is the second carbon, this is the third carbon, and this is the fourth carbon. And this is another branching here. We can take this to be 4 prime. Okay, in naming this, how are we going to do? We are going to say this is a methyl group. We are going to say, and how the parent chain has how many carbon atoms? 4. We will say it is 3-methyl bute. 3-methyl bute 1. The functional group starts from which position? It starts from the first carbon. So it is 3-methyl bute. Bute is because it is butane. It's because the parent chain is 1, 2, 3, 4. That is butane. So 3-methyl bute 1 because the functional group is on the first carbon atom. 3-methyl bute 1 ine because it is an alkyne. So that is the name. The name is 3-methyl bute 1 ine. So that is the name that is being given. Okay, using this name, let's check at the answer column which of the answers is right. Okay, the first answer is 3-methyl bute 1 ine. That is our answer. The answer is not pen-2-ine. The answer is not 2-methyl bute 3-ine. The answer is not bute 1-ine. The answer is 3-methyl bute 1-ine, which is A. You have to share it. Let's get to question number 37. On question number 37, we are told vegetable oil, the vegetable oil we eat every day, vegetable oil are converted into margarine by A. saponification, B. esterification, C. hydrogenation, D. polymerization. These are the different methods, organic methods. But is that the way we convert a vegetable oil to margarine? No. One of them is surely going to be the answer. Let's have it here. Okay, it should be noted that unsaturated fats are found in food plants. There are food plants that contain unsaturated fats. Such food plants that contain unsaturated fats are vegetable oil that we are talking on. We have nuts, the nuts we eat every day, and we have some seeds that contain unsaturated fats. Therefore, these unsaturated fats, the only way we can convert them to margarine, is by hydrogenation. They will undergo hydrogenation because they are unsaturated. We need to add hydrogen atoms there for them to be saturated, solid margarine. So we say vegetable oil is converted by hydrogenation to give more saturated solid margarine. So in that process, that is how we can get our margarine from our vegetable oil. Let's get to our answer column. Which of the terms represent this conversion? Here we will see that the only term that gives this is a C, hydrogenation. Only unsaturated compound will undergo hydrogenation. So C is our answer. Let's get to question number 38. Question number 38 reads, hydrocarbons which react with ammonium copper 1 chloride solution Hydrocarbon will react with ammonia copper 1 chloride solution, conform to the formula, to the general molecular formula CnHn. CnHn, CnH2n, CnH2n plus 2, CnH2n minus 2. Okay. It should be recalled that CnH2 belongs to the homologous series CnH2 minus 2. So C2H2 plus 2Cl, that is a copper 1 chloride, plus the ammonia is going to give us C2 plus 2 ammonium chloride. This shows that it belongs to the, for which formula? This shows that it belongs to what? It shows that it belongs to CnH2n minus 2, and which is D. Now, 39. Which of the following compound will react together to give which of these compound will react together to give this compound? We have CH3, CH2, CH2, COO, CH3. This is, it should be noted that this is an ester. This is an ester. And esters are formed. Esters are formed when an alcohol reacts with a carboxylic acid. When an alcohol reacts with a carboxylic acid, that's when an ester is being formed. Esters, they have a fruity smell, nice perfume, fruity smells, sweet smells. So in this case, which of the following will react to give this? Here in this compound, you will see, in this compound here, you are going to see that in this compound, this is an alcohol. The OCH3 is an alcohol. The first thing you do is you must first of all write the compound out. Let's write the compound out. Let's write the compound out. From there, you will identify. From this compound, you will see that here this section is from the alcohol, and this section is from the acid, and the acid is 1, 2, 3, 4 from butanoic acid, and this section is from the alcohol, and the alcohol is what? Is from methanol. It's from methanol. So now, an alcohol reacting with an acid will give what we call the ester. So from this area here, that's what we call the ester linkage. We are not after that one. But now, the name is, in naming esters, we have to start with the alkyl group that comes from the alcohol. This section comes from the alcohol, and this section is an N with the acid. So this one is from the alcohol. From methanol, the alkyl group there is the methyl group. From methanol, the alkyl group there is the methyl group. So what then? We will now say this one is noate because of the oxygen. Now there we now say it is methyl, because it is the methyl group comes from the methanol. Methyl butanoate. Methyl butanoate. Let's go to our answer column. Which one gives us methyl butanoate? Methyl butanoate. Now, it is from the methanol and the butanoic acid. So methanol and butanoic acid, which one is that one? Methanol and the butanoic acid. Our answer for 39 is B. It takes us to question number 40. Okay, C12H26 and C12H12O11 are both covalent. C12H22O11 is soluble in water, while C12H22 is insoluble. This is because C12, H12, H22, O11 has a high, or a higher molecular mass. B, it has a high molecular mass. B can be hydrolyzed. C forms hydrogen bonds with the solvent. And D contains stronger van der Waals forces. They said this and that are both covalent. This one, the C12, the one that contains oxygen, is soluble in water, while this one is insoluble. This is because this one does what? If you look at it, what is a hydrogen bond? A hydrogen bond is a bond formed when hydrogen that is attached to a highly electronegative element attaches itself to the lone pair of electron of another highly electronegative element which is covalently bonded. In that case, we are saying that a hydrogen bond, this one can form hydrogen bonds with water. This one can form hydrogen bond with water. So it forms hydrogen bonds with the solvent. So C is our answer. 40 is C. 41, the tensile strength of natural rubber. The tensile strength of natural rubber is increased by heating it with what? The rubber, the natural rubber, to increase the natural rubber, especially the one they use for tires or to produce the tires for our vehicles, to produce other ones. What makes the rubber to have that strength? After receiving the rubber from the natural from the source. After receiving the rubber from the source, what gives the rubber that strength? What gives the rubber the strength is there are some certain element that will give the rubber the strength. That's why we say this process is called vulcanization. This process is called vulcanization. Rubber is heated with sulfur. Rubber is the rubber, after producing it from the initial source, from our farms, it is now heated with sulfur and accelerated and activated at a temperature of 140 to 160 to achieve and improve elasticity, resilience, tensile strength, viscosity, hardness, and weather resistance So, which of the element from all these, which of the element is there that will give the rubber that tensile strength from what I've given you here? We have sulfur. Let's see if sulfur is our element that can give us that strength. So our answer for 41 is B. Question number 42. How many moles of oxygen are required to burn 1 mole of butane completely? How many moles of oxygen are required to undergo or are required to burn 1 mole of butane completely? Well, this is a calculation, and in this calculation, let me show you how you can do this. They just need how many moles? 1 mole of butane is just an answer, just writing it. How many moles are required for complete combustion of an organic compound? They result in what? In excess oxygen. A hydrocarbon is completely burnt or combusted to carbon dioxide and water. So they are asking us, from this equation, we have, this is 1 mole of butane reacting with 6 moles of oxygen to give carbon dioxide and water. So how many moles of oxygen? The moles of oxygen that are required for this are 6 moles from our equation. 6 moles for the complete combustion. It's just an equation. You write an equation and you have your answer. Our answer is C. The answer is C. Okay, let's go to question number 43. Question number 43 has to do with some precipitation of ions. Okay, we are told, which of the following solutions react without producing a precipitate? Which of the following solutions react without producing a precipitate? A, we have barium chloride plus sulfuric acid. We have, when this happens without producing a precipitate, when this happens, barium sulfate precipitate are being formed. Now, when, for hydrogen chloride and nitric acid precipitate are also formed there. No, they may not be precipitated here because I see the number of ions are almost the same. Let's go to C. Precipitate are formed. Zinc chloride plus silver nitrate precipitate are formed. Copper chloride, copper 2 chloride, and sodium hydroxide precipitate are formed. But they are asking us which of the following solution react. Which of the following solution react without producing a precipitate? The only one that have equal number of ions here is B. And when this one they react, there will be no precipitate formed in B. Let me show you how this works. In B, that is in B, this is what will happen. In B, we have hydrogen chloride plus nitric acid. Plus potassium nitrate. Sorry, plus potassium nitrate will give us nitric acid and potassium chloride. Why I say they are not precipitated to be formed here is because we have hydrogen. When they want to dissociate, we will have hydrogen ion plus chloride ion. When they want to dissociate, we will have potassium ion and nitrate ion. When they want to dissociate, we have hydrogen ion and nitrate ion. And when this other one dissociate, we have potassium ion and the chloride ion. If you look at it, this one will cancel out this, and this one here will cancel out this. Chloride will cancel out this. Potassium will cancel out this, and nitrate will cancel out this. So the ions will cancel out each other. For that reason, no precipitate is formed. For that purpose, our answer for this is B. Our answer for this is a B. Once more, I want to appreciate those of you who have subscribed to our channel. But for those of you who haven't subscribed, please like this video, share to other learners, and most importantly, take your time to subscribe to our channel. Let's continue. Question number 44. Question number 44. The use of silver salt is photographic. Or the use of silver salt in photography is based on the process of A. Oxidation of silver to silver halide. Reduction of silver ion to silver. Double decomposition to form silver halide. And D. Direct combination of silver with halogens. It should be noted that in this question, silver halide, silver halide, I'm talking of halogens of silver. Silver halide, a silver halide salt is sensitive to light. It is sensitive to light. So when the silver halide is decomposed or decomposes into the various elements, the precipitate darkens as it gradually decomposes into silver and the chloride ion. So, for instance, when we have silver chloride and silver chloride precipitate and it decomposes, it produces silver, the silver, not the silver ion, is going to give us a silver solid and the chloride gas which is being released. For that purpose, silver is going to be from silver plus 1 to 0. And the silver plus 1 to 0 is giving us what? That is, silver chloride will give what? Will give a silver solid, which is Ag, plus the chlorine gas that is being released. The silver in silver chloride has an oxidation number of plus 1. Then going to silver solid is 0, because any element in its neutral state has an oxidation number of 0. So it is reduction taking place here from plus 1 to 0. So in our answer column, the answer for this question is B. Uh, 44 is B. Let's go to question number 45. A sample of local gin. Gin is alcohol spirit. That is we drink. Alcohol, the alcoholic spirit that we drink. In the laboratory, we call it ethanol. Call it ethanol. It has a certain percentage of alcohol in it, and it is very, very volatile. Okay. In this case, a sample of a local gin that turned brown through storage in a rusty metal drum can be purified by about 4 different methods given here. But it should be recalled here that when the gin, or what we call the alcoholic spirit, when the alcoholic spirit is stored in a metal container that can undergo rusting, after a period of time, there's corrosion, and the alcoholic spirit get mixed up with the rust, giving the brown color that has been described here. Now, we need to purify this and get back the alcoholic spirit, which is called the gin. What is the method that can be used for this? It should be remembered that, it should also be remembered that, for example, the metal rust is what we call the hydrated iron 3 oxide. When iron react with air, when iron react with a moist air, if you keep an iron, be it an iron nail, in a moist air or to sleep overnight, the next morning you will notice that there's some rust attached to it because of the reaction of the iron with the moist air. So the formula we give here is hydrated iron 3 oxide, which is the Fe2O3 water, the hydrated iron 3 oxide. So this hydrated 3 oxide mixed with the alcoholic spirit. How can we do to separate the alcoholic spirit? Now, the only way we can do this is the two of them, they have 2 different boiling points. They have two different boiling points. And the technique we can use here is simple distillation. So a mixture of hydrated iron 3 oxide and the alcoholic spirit in a distillation flask is being heated. When the spirit, when it's being heated and it boils, remember that the spirit has a lower boiling point. The spirit will evaporate and get into what we call a condenser. It will evaporate as vapor and get into what we call a condenser. The condenser will now condense and will now make it to condense. It condenses and is collected as liquid spirit. It condenses and is collected as liquid spirit. So our method for separating it is simple distillation. And B is our answer here. B is our answer for our separation, distillation. Why I say it is simple distillation, I'm trying to differentiate it from the fractional distillation of oil. In an oil industry, the different hydrocarbons, they have different boiling points that are being separated based on their boiling points. So the fractional column is the distillation column is fractionalized into different boiling points. Hydrocarbons are being distilled off at their different levels corresponding to the different boiling points. That's why I say it is simple distillation. Okay, let's get to question number 46. In the extraction of iron in the blast furnace, the role of limestone is, the limestone is very, very important. Limestone is very, very important in the extraction of iron, because the limestone will decompose, will decompose under the heating. Limestone will break down or decompose to give us the calcium oxide and the calcium carbonate. I mean the calcium oxide and the carbon dioxide. So the calcium oxide is very, very useful. The calcium oxide is the one that will be used to extract the impurities that are found in iron during the extraction of iron in the mine. So now we say the role of the limestone is to decompose the iron ore. It does not decompose the iron ore. B, the role of the limestone is to remove the silicate impurities. Excellent. I told you the calcium oxide that is being produced when the limestone decomposes, the calcium oxide now reacts with the silicon dioxide and form what we call the calcium silicate. That's what we call the slag, which is also used in the tarring of our roads. So that is the answer for this. The answer for that one is to remove the impurities. For the removal of the impurities. Removal of the impurities. That is very, very important. The calcium silicate. So the answer is answer for 46 is B. Answer for 46 is B. B is 46. 46 is B. Now let's go to question number 47. For question number 47, which of the following methods is most suitable for preventing the rusting of petroleum pipelines? Which of the following method is most suitable for preventing the rusting of petroleum pipelines? In our pipelines, there are many methods we can use to prevent them from rusting. And when they get rust, petrol can get burst and there will be leakage. So, which will has environmental hazard. For that purpose, the method that will be used, the most suitable method that will be used to prevent the rusting of petroleum pipeline will be painting it. We need to paint the pipelines with a coating, a paint that will give a coating that cannot react with water or with oxygen, leading to rusting. So painting, I don't need to go to greasing, electroplating, cardiac protection, and magnesium. The only thing is by painting it. So 47, painting is our right answer, which is A. Question number 48. Question number 48. Soldering wire. Soldering wire is an alloy of tin. Soldering wire is an alloy of tin and aluminum. Tin and aluminum. Tin and lead. Tin and iron. Tin and copper. Soldering wire is an alloy of tin and lead. So it is lead. Thank you. Question number 49. Which of the following pollutants is associated with genetic mutation? Pollutants. There are pollutants that can result from war. There are pollutants that can result from war, from environmental degradation, and other from industrial activities. So which of the following pollutant is associated with genetic mutation? Carbon 2 oxide, carbon 2 oxide, radioactive fallouts, biodegradable wastes, sulfur 4 oxide. It should be recalled that the only pollutant that can affect the genetic constitution, the only pollutant that can affect the genetic constitution or disorder the arrangement of genes, or what we call genetic mutation, is radioactive mutation. With genetic mutation are radioactive fallouts. Radioactive activities are the only thing, like a nuclear reaction in nuclear centers or during war, atomic bombs, all those things that result in a nuclear activity emitting radioactive waves or isotopes are the one that can result in genetic mutation. So our answer for this particular question is B, radioactive fallout. Radioactive fallout. 49 is B. And the last question, question number 50. Effects of water pollution include the following, except it should be noted that for the purpose of revision, water pollution, water can be polluted in different ways. Water pollution, it could be from wastewater. Water pollution can come from wastewaters. It can come from waste, from domestic waste, industrial waste, agricultural waste that may result from agricultural waste that may result from maybe fertilizer and other chemicals for spray or other type of things that are being taken off by runoff into the waters. They help to pollute the water. Industrial activities help to pollute the water. Domestic waste from our houses from hotels, all those things like that are being carried out by runoff into our waters. All these are the sources of water pollution. Now, the effect of water pollution will include the following, except 1, depletion of dissolved oxygen. Yes, that is one of the effects of water pollution. B, depletion of heavy metal ions. Water pollution cannot deplete heavy metals ion. Ecological changes. When there is pollution in water bodies, there is going to be ecological changes. For instance, the increase or the runoff, including containing fertilizers from our agricultural farms into the water bodies, can cause the rapid growth of algae in our water bodies. And automatically it can change the ecological system. Increased turbidity. Of course, there's going to be an increased turbidity in the water bodies. There's going to be a depletion of the dissolved oxygen. That's why the dissolved oxygen in the waters is going to decrease, resulting in the death of some of the aquatic organisms. So the only thing that is not going to be involved in water pollution is depletion of heavy metal ions. So our answer for question number 50 is B. So our answer here is going to be, for 49 we had B, and for 50 we had B. So thank you. We have come to the end of our class discussion today for our paper for the West African Examination Council, especially the West African Senior School Certificate Exam, Chemistry Paper 2. So this is the end of our discussion today. Once more, my gratitude goes to my school, gist.com, for making available to us the question paper. And I want to also thank those of you who have taken your time to subscribe to our channel. And above all, for those of you who haven't subscribed to our channel, please like the video, share to other learners, and most importantly, take your time and subscribe to this channel so that other papers that we are going to be solving will come directly to you. Thank you very much.